Alright guys, welcome back to Underground Science. In this video, we'll be talking about the auto-ionization of water. Alright, so let's go and get started. So the auto-ionization of water, I can't say that word for some reason, is pretty much it's a constant value that apparently the researchers or whoever found it, right, that, well first let's say that the pH of water is 7, right, but how? Because the researchers or whoever found it said that at 25 degrees Celsius, the concentration of the H plus cations or hydronium, right, which identifies the acidity of whatever solutions in there, the concentration of H plus is equal to about 1.0 times 10 to the negative 7th molarity. All right. And they said that the concentration of OH, right, in the water at 25 degrees Celsius is also equal to 1.0 times 10 to the negative 7th molarity. And again, guys, molarity, or not again, I didn't say this, but molarity is equal to moles over liters. All right, so and that represents concentration. So I'm going to write that down. So the concentration is molarity. So as you guys can see here, remember that in the pH scale, which will be a future video, the hydrogen cations represent the acidity part of it, so the pH below 7, and the hydroxyl anions represent the pH above 7, so the alkalinity, right, or the basicity, the alkalinity. And if we see that at 25 degrees Celsius in water, we have the same exact concentration of both, that's why water is said to be a pH of about 7, all right? So instead of writing it like that, let's write it like it's actually supposed to be written, a pH of 7. All right, so that's why. So that's the auto-ionization of water. It pretty much means that water will automatically ionize, right? Ionize, or it's going to automatically dissociate into its constituent forms, into its ions. So what does that mean? Let's go and look at it. Remember when we talked about the video where the amphoteric nature of water, where it can act like a bronzolary acid and a bronzolary base? Well, that's what the auto-ionization of water means. So it automatically ionize into our hydronium and hydroxyl groups. So let's go and see what I mean by that. So remember, water, if we react two water molecules, they can act as a bronzolary base or a bronzolary acid, right? So either this one can act as a bronzolary base or this one can act as a bronzolary base. And then again, or either this one can act as a bronzolary acid or this one can act as a bronzolary acid. That's the amphoteric nature of water. So if we react with this, react two water molecules, we'll see we automatically form hydronium and OH, right? So that's the auto-ionization of water, that water will automatically ionize into its constituent ions, all right? So hydronium cation and OH. And at 25 degrees Celsius, both the concentrations of these are the same, right? 1.0 times 10 to the negative 7th. Okay, so that's the amphoteric nature of water. So now let's discuss the auto-ionization. Why can't I say that word? The auto-ionization constant equation. So the way we represent that is we represent that as Kw, all right, the auto-ionization constant of water. All right, so the Kw is equal to, we said at 25 degrees Celsius, the concentration of our hydronium, or our H plus, is going to be 1.0 times 10 to the negative 7th. Remember when writing any Kw or Ka equations, we do the products, right? We multiply the products over the reactants, but this time the reactants are only water. We said in our previous video that we don't count water in our equation for Kw or any Ka or any ionization constant equation because water is a liquid and its concentration is going to stay constant. So the concentration of H3O plus we said was 1.0 times, so 1.0 times 10 to the negative 7th, right? That was the concentration of H plus or H3O plus times the concentration of OH minus, which is also 1.0 times 10 to the negative 7th, because it has to be, because if both concentrations are equal, that makes sense why water has a pH of 7, right? And then if we multiply those together, we'll get our final auto-ionization constant value that we'll be using throughout our acid-base videos is 1.0 times 10 to the negative 14th. All right, so that's our final auto-ionization constant value, and that's what I wanted to get through in this video. And so I really hope this video made sense to you guys. I hope to see you guys in my future videos. We'll talk about more cool topics about biochem, and physics. See you guys later. Stay safe. Make sure to hit that notification bell, like and subscribe. All right. And so, yeah, see you guys later.